Today's lesson is about verifying trig identities. First of all, here are some tips for verifying trig identities. Start with the more complicated side and rewrite everything in terms of sine and cosine. Whenever you see 1 plus or minus cosine x or 1 plus or minus sine x as a denominator, using conjugate multiply to simplify. Remember that when 1 minus cosine x or 1 plus cosine x as a denominator, you are supposed to get a sine squared x as a denominator after you did a conjugate multiply. When 1 minus sine x and 1 plus sine x as a denominator after you did a conjugate multiply, you are supposed to get cosine squared x as a denominator. When you do verifying trig identities, try to remember the following identities. You have reciprocal identities, especially for cosecant and secant changing into sine or cosine. For ratio identities, for tangent x and cotangent x, how use sine cosine to stand for that. For Pythagorean trig identities, this one is more important. Now let's go to example. For number 1, we know left-hand side is more complicated. Therefore, I put the left-hand side equals. Change everything into sine and cosine. So I got tangent x will be sine x over cosine x. So first of all, I will working on the multiplication of a fraction. You can put over 1. Cosine x, I bring down, then plus. Denominator multiply, that's cosine x. Numerator multiply, that's a sine squared x. So this time we will do operation of addition of a fraction. Now denominator multiply, that's a cosine x. Cross multiply, we got the cosine squared x plus sine squared x. We know for cosine squared x plus sine squared x, that's equal to 1. So we got the 1 over cosine x. That's equal to secant x. That's the right-hand side. So we finish this proof. Now let's go to number 2. Left-hand side is more complicated, so we go to left-hand side. Change everything into sine cosine. For cosecant x, that's a 1 over sine x minus sine x. For denominator, we have sine x times 1 over sine x. So we do the operation. This is a sine x over 1 multiplication. I can reduce. We got the 1 as denominator. Look at the top. I will do subtraction of a fraction. Therefore, denominator, that's sine x. Then we got 1 minus sine squared x. Now we move on. That's 1 minus sine squared x over sine x. Don't rush change in this one into cosine squared x. Don't do that. Always check what kind of a form we needed. We need a cosecant x minus sine x. It's not only one term like a cosine squared x. Therefore, we just need to separate this fraction like this. 1 over sine x minus sine square x over sine x. Then we can reduce, this is 1, this is sine x. Therefore, 1 over sine x, we know that's cosecant x minus sine x. That equals the right-hand side. We finish proving. Let's go to number 3. We know left-hand side is more complicated, so we start with the left-hand side. Do not rush into change everything into sine and cosine, because for this problem, denominator is tangent beta. This is a tangent beta. Then we can just do the operation of addition of a fraction for the left-hand side. So we're working on this. We got the tangent beta as a denominator. Then top, we do the cross multiply. You will get the 1 plus tangent square beta. If you know secant square beta minus tangent square beta equals 1, then secant square beta equals 1 plus tangent square beta. If you know this formula, then you can just directly get secant square beta over tangent beta. If you cannot remember this formula, then denominator don't change, because tangent beta is a denominator on the right side. So we change the tangent into sine square beta over cosine square beta. Therefore, denominator, that's the tangent beta. We still do addition of fraction, that's cosine square beta. Then cosine square beta, we do cross multiply at sine square beta. This part, that's 1. So we got to 1 over cosine square beta over tangent beta. 1 over sine square beta, that's a secant square beta over tangent beta. That's the right-hand side. Now we finish this proving. This problem tells us that when you do verifying trig identities, always analyze both sides so that you can get the better way to figure this out. Now let's go to number 4. We know left-hand side is more complicated. Then when you analyze the left side, you see the signal for conjugate multiply. So for this part, you can just bring down 1 plus sine theta. Denominator, that's cosine theta, plus we do conjugate multiply for 1 plus sine theta. We got the 1 plus sine theta and then 1 minus sine theta. Don't forget, multiply by 1 minus sine theta to the numerator. We know that when you do conjugate multiply, we are expected to get cosine square theta as the denominator. So we work this out. That's 1 minus sine square theta. That will be cosine square theta. So I bring down 1 plus sine theta, cosine theta. And I add this one, change into cosine square theta. Look at the top, we got the cosine theta times 1 minus sine theta. Then we can reduce 1 cosine theta. Remember, don't do distributive property during the process of verifying trig identities, because we want to reduce the factor. So we got the cosine theta as a denominator. Then to the top, I got the 1 plus sine theta. And for this part, that's 1 minus sine theta here. Then I combine like terms, cancel out. We got the 2 over cosine theta. That is 2 secant theta. That's the right side. We finished the proof. Now let's go to number 5. For number 5, this gives you the signal to do the conjugate multiply. Therefore, for this trig identity, we need to start with the right-hand side. That's cosine y over 1 minus sine y. We do conjugate multiply. 1 plus sine y. Top and bottom. The expected answer will be cosine square y as a denominator. So we do these two, we got the 1 minus sine square y, because a plus b times a minus b, you got a square minus b square. Therefore, we got the cosine square y. Top will be cosine y times 1 plus sine y. Then reduce. We got cosine y. Therefore, we got the 1 plus sine y over cosine y. Then check the left side. For the left side is no fraction. Therefore, we separate 1 over cosine y plus sine y over cosine y. So we got secant of y from 1 over cosine y. Sine y over cosine y, we got the tangent of y. That's the left-hand side. So we finish this proof. Now let's go to number 6. For number 6, we know that's the left-hand side. You need to change everything into sine, cosine. For the top, stay. For the denominator, I change tangent square x into sine square x over cosine square x. Then we're working on the denominator. This is over 1, then you do cross multiply. Top, stay. Denominator, we got 1 times cosine square x, that's cosine square x. Cross multiply, you got the cosine square x minus sine square x. Before you do operation of a complex fraction, check whether you have the same common factors on the numerator or on the denominator. For cosine square x minus sine square x, this is both on the numerator, so you can reduce. For cosine square x this time, then you can jump. You got the cosine square x. That's equals to right-hand side, and we finish proving. Now let's go to number 7. We got a signal for conjugate multiply. expected value will be sine square x. So we get started with the left-hand side. That's sine x. We need to change into 1 plus or minus sine x or 1 plus or minus cosine pattern. Therefore, I change into 1 plus cosine x. Then we need to do conjugate multiply for this one. 1 minus cosine x and 1 minus cosine x. I bring down this cosine x minus 1 over sine x. We know for these two, we got 1 minus cosine square x. That is sine square x. For the numerator, we got the sine x times 1 minus cosine x. Then I bring down this part. That's cosine x minus 1 over sine x. Then reduce, here's 1. This is a sine x. Since we got the same denominator, that's why I can put this together. I got the 1 minus cosine x plus cosine x minus 1. Then I combine like terms. All this gone. We got 0 over sine x, that's 0. So equals the right-hand side. We finish proving. Now let's go to number 8. We still need to get started with the left-hand side. We know sine square theta plus cosine square theta, that's 1. So we got 1 plus cotangent square theta changing into sine and cosine. That will be cosine square theta over sine square theta. Denominator is 1 plus sine square theta over cosine square theta. So we do operation of additional fraction to the top and bottom. We got denominator multiply, that's sine square theta. Then cross multiply, we got sine square theta plus cosine square theta. Let's do the operation of additional fraction to the denominator. So we got cosine square theta cross multiply. That's cosine square theta plus sine square theta. We do know that sine square theta plus cosine square theta equals 1. If you didn't know this, you can still reduce because both on the numerator position. Therefore, this time I can jump. For denominator, we can jump up or drop down. We got the cosine square theta over sine square theta. That is the cotangent square theta equals right-hand side. We finish this proof.